In the previous examples, we discussed the importance of talking about the form, direction, and strength of a relationship. When we talked about strength, we kind of loosely discussed it. We said, oh, the points are tight to a curved form, and this is a weak relationship because the points are scattered about the line, but we didn't put a number to it. The correlation is going to be a way we can quantify this relationship and put a number on the strength of the relationship. Correlation, which is denoted by lowercase r, is a number that falls between -1 and 1 that describes the strength and direction of a straight line relationship between two quantitative variables. A negative sign indicates a negative association, and a positive sign on the number indicates a positive association. If the correlation is 0, there is no linear association. If it's perfectly +1 or -1, it's a perfect straight line. To picture some correlations, we've created some scatter plots and posted them here for you. In the top left, the correlation is 0. That is, when we calculated the value, it came out to be no linear association. If you were to fit a line to that, how would you fit a line to it? It looks like a cloud of points, so you wouldn't know which direction to fit a line to it. And therefore, the mathematical calculation produced a correlation of 0. Now the next scatter plot has a correlation of -0.3. The minus sign tells us it's a negative association, so it's a downhill trend. And the 0.3 is closer to 0 than it is to 1. So it tells you the points are pretty scattered around the line. This is a weak linear association. In the next plot over, the correlation is +5. The positive sign tells you that if we were to fit a line to this, it would go uphill. The 0.5 being halfway between 0 and 1 indicates that this is a moderate association. The points are scattered about the line, but they're tighter to the line than the 0.3 plot before it. In the bottom left, we have a minus sign, which shows a downhill trend. And the 0.7 is getting closer to 1, so you can see those points are getting closer and closer, tighter to the line. The next plot shows +0.9. The positive shows an uphill trend, and the 0.9 being close to 1 is shown in this plot by the points being so tight to the linear form. And last but not least, -0.99. Negative is a downhill trend, and the 0.99 being so close to 1 lets us know that these are extremely tight to the linear form. The scatter plot shown on the top that plots perceived attractiveness against perceived intelligence also came from the StatCrunch data repository. Notice that the R is 0.76. The positive number lets us know that if we were to fit the best line, it would have an uphill trend. It's a positive association. The 0.76 is closer to 1 than it is to 0, so it's letting us know it's a pretty clear linear form. This correlation would be even higher if we could remove this value and this value. Those two values are probably making the correlation much lower than all the other points. If those 2 points were removed, this correlation would probably be closer to 1. In the next plot, the correlation is -0.91. Notice that the minus sign is saying there's a downhill trend. The 0.91 tells us the points are pretty close to a linear form. Now I'm sure a lot of you see the curve in the plot. So it might be better if we were trying to fit a model to make predictions if we were to fit a curve. However, this correlation only measures the straight line relationship to the variables. The straight line that fits the best probably looks something like this. And since the points are scattered about that straight line, but they're fairly tight to it, none of them are too far away from the line, that's why it's indicating a correlation closer to 1. So some final notes. R has no units and won't change if we change the units of measurement. It ignores the distinction between explanatory and response variables. and it is strongly affected by outliers. You should always start with a plot of your data. So always give a plot of your data when reporting R. Notice in the scatter plot above on the weight of vehicles versus the miles per gallon, the gas mileage, if we were to report our correlation of negative 0.91, our audience may immediately think this is a strong linear association. Until we see the actual scatter plot, we wouldn't know that it's actually maybe better described by a curve. You should never just report R alone. R is also highly sensitive to outliers. It's strongly affected by a few outliers. We talked about that in the second to last example. You can visit the website of your textbook and click on the statistical applet to explore if you would like to see how much R is affected by outliers.